So let's have a look at the left part of the climate wall. So we have the humid tropics here, which implicates high temperatures and intensive rainfall, so high rainfall. And you have to think that although we show here the soils which are dominantly formed by climate, each soil always has had the impact of the other soil forming factors as well. So it's the dominant factor by which they are shown, but of course it's an interplay of the various soil forming factors. And in some of these soils of the humid tropics, they're also old of age. For instance, these extremely red soils that you find in Africa, for instance, they've been under a very long time under the same climate. An intensive climate which is causing leaching. So these are the oldest soils you can find, for instance in Australia, in Brazil, in Africa, large parts of Africa, and they've been depleted of many components that were originally in there. So silica and other components, and they look rather homogeneous. So and in fact they are. And what is left are clay-like minerals that have a very low buffering capacity. Most soils in the world, they have a negative charge, so they can attract and buffer positively charged elements, the plant nutrients for instance. But these soils are nearly neutral, so they have a very low buffering capacity. They can even have a positive charge. And that means, of course, for management that they are very difficult to manage because they are low in nutrients, and even if you add nutrients in your management system, the soils have a low capability to buffer them. But of course there are always smart ways to manage even difficult and poor soils, and one of the keys of managing these soils is organic matter management. And if you look at this very red soil, your eyes are a bit betrayed by the color, because this is actually a soil with a high organic matter content. It has 1% up to 1 meter. So, and that is key because organic matter also has a charge. It also can release nutrients, but also buffer nutrients. So that is key in preserving and managing these soils. But otherwise very difficult. Another problem in these soils is the phosphate retention capacity. They are very low in phosphate, but if you add phosphate, they have the capacity to bind it so strongly that plant roots cannot take it up. So that's another aspect of managing these soils. So preservation of the topsoil in farming is extremely important. If you look to the left part of this range of soils, you also have soils which are similar but a bit different, with clay, rich clay subsoils in the tropics. These are, well, in the temperate area we also have soils with clay movement, so over 100,000 and 10,000 years clay moves through the profile and accumulates in the subsoil. But these are tropical clays, which means also again this lower buffering capacity and low nutrient containing. The problem is that they are acid, so in the very humid tropics, in the Amazon, in Southeast Asia, in Borneo, you find particularly these soils, these more yellowish soils, which are more gibbsite, so aluminum oxides and hydroxides, where these reddish soils are actually iron related, so hematite, oxides of iron. And here you find these yellowish orange soils, and they have a low aggregate stability in the topsoil because clay has moved to the lower parts. You have silty topsoils. Organic matter, as in the other soils, is the primary source for soil fertility. And if you lose the topsoil by excess with heavy machinery, removal of trees, vegetation, you get the impact of the high precipitation, and then the topsoil can be lost in a matter of days and weeks. And then you are left with this very poor acid, aluminum containing subsoil. So again, very particular management needed for these type of soils.